geometric proofs, which means now the proofs will have shapes instead of just equations. Sounds a lot harder, but most of it you have done, just not within a proof. So there are a few properties here that you already know: reflexive, symmetric, transitive. They're just listed with a congruent symbol instead of equals, so we're not going to go over those again. But we do need to go over this. So sometimes it's acceptable to use an equal sign, and sometimes it's acceptable to use congruent. The difference is when it's talking about a number, you use equals. When you're talking about a figure or a shape, you use congruent. So some examples, if you want to jot them down, would be like x equals 5. It's an equal sign because we're talking about a number. The measure of angle A equals 60. We're talking about a number, so it's equals. You could say the measure of angle A equals the measure of angle B. So even though you don't see a number, it's talking about the measure of a number, those two angles being the same. Same thing is true for segments. XY equals AB. If it doesn't have the segment over the top, it's talking about the length. So that's a number. So those are all examples when you should use an equal sign. So congruent symbol would be like angle A is congruent to angle B. So we're just talking about the two figures being the same shape. With segments, it looks like this. XY, segment XY is congruent to segment AB. So anytime the segment is there, it's congruent. If the measure is not there, it's congruent. Okay? So we're going to go through these and decide which ones are acceptable and which ones are not. So we'll put a check for it's acceptable and X for it's not. So do you think this first one is acceptable?
No.
No, it is not, because the measure should be there if we're talking about equals. Okay, next one.
Yeah.
Yes, good. Next one.
Yeah.
Yes, that one's probably the trickiest one. The reason it's equals is because the segment's not over the top. Okay, top right.
No.
Nope. This one.
Yeah.
Yes, that's good. Measure is equal. And then the last one, that's a congruent symbol, even though it doesn't really look like it.
Yeah.
Yes. Okay, so the first thing we're adding to our chart today is changing from equal sign to congruent. So I'm going to put that in the chart. First one, definition of equal. So the explanation is if it's already congruent, then you can change it to an equal sign. So an example of this would be if segment AB was congruent to segment XY, then you could change it to they equal each other. And you'll understand why we have to do this when we do our first proof. Next one, same exact thing, it's just backwards. Definition of congruent means if they are equal, then you can change them to congruent. So same exact thing, just backwards, but I'm going to put a different example just so you can see. So like if it was an angle, measure of angle A equals measure of angle B, you can change that to angle A is congruent to angle B. So the first proof, you'll see how this is used. So go ahead and make your 2-column chart. Statements, reasons, and list the givens. So XY equals 9 and AB equals 9. So we're trying to prove that those two segments are congruent. So what do you know about those two segments based on what they told us already?
AB and XY are equal to each other?
Right, they have to be equal to each other since they both equal 9, right? So let's say that AB equals XY. What do you think the reason is?
Because they both equal each other?
Yeah. So there's two things you could call this. You could call this substitution. I prefer using transitive. That's the one I was talking to you about earlier. It says if two things equal the same thing, they have to be equal to each other. So I'm going to put transitive. But like I said, substitution technically works there too. Okay, is that exactly what it wants us to prove?
No.
So we need to change it and say that because they're equal, they also have to be congruent. And that's the definition, one we just wrote. So the easiest way, you could check your chart and see which one it should be, but the easiest way for me to remember which one to use is whichever symbol I just wrote. That's the definition of what I put over here. So definition of congruent. And that's all for number 1. Any questions on that? Okay, let's try 2. So we've got a new property for this one. This is called the definition of right angle. So anything that's a definition is technically not on your property chart, so that's why it's good to write these down, because it won't be given to you on a test. So the definition of a right angle basically says that if an angle is 90, then it's a right angle, right? We just have to write that in our chart. I'm going to write that as an if-then statement. So if an angle equals 90, then it's a right angle. So for example, if you had in your proof that the measure of angle B equals 90, then you could say angle B is a right angle based on this definition. So that's going to be useful on this proof. So let's go ahead and list the givens. So measure of angle A equals 90. And angle A is congruent to angle B. So we're trying to prove that angle B is a right angle. So sometimes it's good to think about the end and what you would have to prove right before that to get there. So if we could prove that B was 90, couldn't we get to that last step? So look at our statements. Is there anything we could do here to say that B is 90?
Well, angle A is equal to 90 and angle E is congruent to angle B, so angle B is equal to 90.
Right. You're right, but we have to do one little technical step first. Since this is congruent and this is equal, you can't substitute unless they have the same exact symbol. So can we change this to where they're equal first?
Yeah.
Yeah. So let's do that and then we'll substitute. So the measure of angle A equals the measure of angle B. So that's the definition of equals. So now that they have the same exact symbol, and this says measure A and not just angle A, now they're exactly the same, and you can substitute. So line 4, I'm going to put measure of angle B in place of measure of angle A. Does that make sense? I took A out and put B in its place. So that's substitution. Okay, what could we say now?
Definition of right.
Good. Yep. So we could say angle B is a right angle. Definition of right angle. Because it said if an angle is 90 degrees, which it was, then we could say it's a right angle. Okay, we've got another property to add that we're going to use for number 3. Pretty much the same exact thing, but it's a straight angle instead. So this is definition of straight angle. So if an angle equals 180 degrees, then it's a straight angle. So the example, if we prove that the measure of an angle is 180, then we can prove that that angle is a straight angle. Okay, let's try number 3. Givens first. So right before we prove that S is a straight angle, what do you think we're going to have to say about it?
Right before you prove that S is a straight angle, what do we have to prove about it?
Yeah.
That is equal to 180.
Good. So if we could figure out a way to say that S equals 180, then we could say it's straight. So we already have that angle N equals 180. So if we could start substituting some angles and say that S is 180, then we could get there. So do you see anything we could substitute right now? We can't substitute this because that's the measure of N, that's just angle N. We can't substitute this because same reason. So what if we change this to equals first, and then we'll have all measures, and then we can substitute stuff. Okay, so line 4, measure of angle N equals measure of angle P. What's that called when we change it to an equal sign?
Definition of equals.
Yep, definition of equal. Okay, now that we have all the angles being measures and with equal signs, now we can start substituting some stuff. So we have N is equal to P is equal to S, and N equals 180. So what do you see that we could substitute? You just want to pick one and see if it helps. Sometimes that's the best way to go about a proof.
Well, if we measure of angle N is equal to measure of angle P, so if we switch measure of angle P is equal to 180,
Okay.
and then that's equal to S,
Yep.
and then we can do
You got it. Yep. We just need to write each line. So we're going to take N out up here and put P in its place. Measure of angle P equals 180. So that's substitution. And then this tells us that P and S are equal. So we can replace P with S. Substitution again. So now can we prove that S is a straight angle?
Yeah, now we just have to use the definition of right.
Yes, except straight.
Oh yeah, straight.
Angle S is a straight angle. Definition of straight angle. Okay, we've got two more things to add to the chart. So the next one will be useful for proof number 4. This is the definition of midpoint. So if a point is the midpoint, then it divides the segment into 2 equal parts. So, for example, if it said that, I'll use the same letters, B is the midpoint of AC, then you could say that AB equals BC. Here's a picture. So these two pieces are congruent or equal. So let's try proof 4 now with that information. This one has scared a lot of people because it's got a picture, but it's actually, I think it's easier than the other two. So first, B is the midpoint. Of AC. Then it tells us what those two segments are. So we've done this exact problem before, but not in a proof. There's our first chapter actually. So it might look familiar. It would give you a segment, tell you that a point was in the middle, and you knew to set those two pieces equal and then solve it. So the picture just shows kind of what the givens told us. This piece is 2y, this piece is 3y minus 9. So based on the definition we just wrote, if a point is the midpoint, which B is, then what do we know about these two pieces?
That AB is equal to BC.
Right, so let's say that. Oops, line 4. AB equals BC. How'd you know?
Because B is the midpoint.
Right, so definition of midpoint. Okay, and our goal is to solve that y is 9. So what could we do to solve an equation?
Put the equations there.
right? So couldn't we take out AB and put 2y in its place? And-
Substitution.
Yep, substitution. I'm going to do this all in one line. I'm also going to take out BC and put 3y minus 9 in its place. Okay, and I'm going to solve it pretty quick because we've got a few minutes and one more thing to do. So subtract the 3y and then last is divide. Okay, the last proof is almost identical, but it's an angle instead, and it uses the word bisect instead of midpoint. Same exact idea, it's just an angle. So let's add that to the chart really quick. Definition of bisect. So if a ray bisects an angle, then it cuts it into, two equal parts. What do you have next?
Lunch.
Okay. Can I finish this really quick before we go? Okay. So, for example, ray LM bisects angle KLN. If that's true, then the measure of angle KLM equals the measure of angle NLM. That one's kind of hard to picture, so let's draw what that would look like. Point K, M. Oh, that shouldn't be K, sorry. That should be L. Okay, so if LM bisects KLN, then these two smaller angles are equal to each other. So I'm going to set this proof up and then we'll be done. We're not going to do the whole thing. Actually, I'm just going to explain it. So if LM bisects this, what could you say about these two things?
They're equal.
They're equal. So we'd do all the givens. We'd say these two are equal to each other. And then we'd substitute these two parts like we did on the last one and then solve the whole thing. So it's basically the same setup. The only difference is using the word bisect instead of midpoint. So I will be here after school today if you need any help